Did you ask her, Melissa?
Good afternoon, ladies and gentlemen.
Proceed.
This is Mofokeng speaking. I'm from Adcorp Technical Training Center. I'll be doing with you gas tungsten arc welding. Adcorp Technical Training is one of the training facilities that is well known here in South Africa. We do various trades from boiler making, welding. We do diesel mechanic, electrical, rigging, and construction as well. One of my colleagues will come and present the electrical circuits and connection systems after this presentation of mine. We're gonna start with gas tungsten arc welding. I'm presenting from one of our facilities, which is in Jet Park, and then we have different facilities, which is in Mofokeng, and we have one in Jomorolo, in Kurumane, and Mofokeng as well. So should you need some part of training or get training or do an ARPL, we also do apprenticeship as well. To get to the presentation of today, as we can see the slide, is gas tungsten arc welding, presented by Mofokeng, which is me. I'm a boiler maker and also a welder by trade. I'm a subject expert matter on that. So for this exhibition, we'll be doing gas tungsten arc welding. So what is gas tungsten arc welding? Gas tungsten arc welding, it's a TIG welding. It's always known as TIG welding. Some they call it argon welding. But argon welding, I wouldn't call it argon welding because I will explain on the slides as we go down. Argon is one of the shielding gases that we use to protect the welding from contamination. So first thing that we're gonna start with, it's the hazard identification and control of gas tungsten arc welding.
Lucky?
Yes, sir.
I'm so sorry to interrupt you. We can't see your slide.
You can't see my slide?
No, if you can just share it, please.
Sorry, let me do this. Okay. Share. Can everybody see my slide? My slide now?
If you can just, there we go. I can see it now. Thank you so much.
Yes. As I was saying, I'm gonna start gas tungsten arc welding, and then I was here in hazard identification and control of GTAW, which is gas tungsten arc welding. Here I've done a little bit of safety. We have potential accident or incidents that may happen, and then also we have control measures by the responsible person. So there are some few of the incidents that can happen as we are doing gas tungsten arc welding. So we have to start by safety first. So one of the dangers, as you weld, you can get electrocuted, so you can get electric shock from damaged cable and equipment. So all the machines that we use, they are powered by electricity. They are 380 volts. So it's important to make sure that you check your cables if they are still in a correct standards, and also inspect to control that so that you cannot be injured. You need to inspect the power supply. The power supply is where you are plugging the cables, and also the welding cables. The welding cables, all the people that are doing welding or somebody who is new into welding, we do have the cables, the positive and the negative cable, which one of them, which is the ground, the other one, which is the one that holds the electrode. So one of those cables, they can electrocute you. So those, you must make sure that those cables, they're in good order. And electrodes also as well, an earth lamp for damages, and replace it if necessary. So should you see that the cable is damaged or the earth lamp is not in good condition, you can replace it immediately so that you can avoid being electrocuted. The second one, also danger to the eyes. So you must always make sure that you wear clear glasses when you are taking off the slacks. But in this instance, GTAW doesn't have any slacks, but you can get an arc eye. So you must wear a helmet to avoid burns from the hot materials, because sometimes there is sparks when you are welding, especially if you didn't switch on the shielding gases. The way to control that, you must make sure you use appropriate PPE, you wear correct type of welding helmet, and then also you must also wear a leather apron to avoid burns, and you must also wear glove, and all the time you must wear safety shoes. Safety shoes also doesn't also help you with injury and burns, but also it can help you from falling down off the material. So because they do have a steel cap in front, so it's important to wear safety shoes. And then the third potential accident that can happen when you are doing GTAW will be a fire hazard from ignition of combustible material. So if you are working with electricity, there's always a spark, and you know where there's a spark, there's fire. So you must make sure that where you are welding, there's no combustible material, because it can start a fire. So the best way to control that, do not wear nylon clothing. So specifically, the best PPE I can recommend for you is to wear the flame retardant, the Sasol spec one, the blue one, that is also acid retardant. Other easy flammable clothing, they can catch fire. And do not weld near combustible material. If you are going to weld, you must make sure that you are aware of your environment. Check around if there is no combustible material that can start a fire. And another potential accident that can happen, that would be inhaling nauseous fumes and gas resulting from a welding. So, ladies and gentlemen, you must make sure that wherever you are going to weld, there must always be a well-ventilated area or an open area, or you must do a gas check to see what gases are there around you, or you can wear a mask. So it's important to do that. Gas check is very important when you are going to do welding in an environment that is confined. But the best way that you can do it is to weld it in an open area or well-ventilated area. Another possible accident that can happen, electric shock to the operator. Okay, this one I think I've repeated it. I've explained it. Most of the time when you are welding, you are using two cables. The other one is positive, the other one is negative. You must make sure that you wear the correct PPE. And also another way of controlling this, when you are welding, you should not weld in a condition where it's wet. Like welding should not be done in any wet condition where the welding equipment can come into contact with water. As you know, all of you ladies and gentlemen, or if you are not aware, water is a good conductor of electricity, and all the equipment that we use for welding, they use electricity, so they will conduct and then the current will flow through. So it is important to make sure that where you are welding, the place is not wet. I'll start with the introduction to the GTAW, as we have completed the safety of GTAW, which is gas tungsten arc welding. The primary consideration in any of the welding operation is to produce a weld that has the same priority as the base metal. So welding, it is mainly done because we are trying to join two material that is of the same. So material of the same, like we are welding steel. So the stainless steel, you'll join it with the stainless steel. So the base material must have the same properties. As well as the same properties as well as the base metal. So even the consumables that you are going to use to weld, they must be of the same properties. So if you are going to weld the stainless steel, you must have the same properties. Like the filler wire must have the same properties of a stainless steel. So you cannot weld a stainless steel on a carbon. Such weld can only be made if the molten puddle is completely protected from the atmosphere during the welding process. The second one, otherwise, the atmosphere, oxygen and nitrogen will be absorbed in the molten puddle and the weld will be porous and weak. So when you are welding two metals, you must make sure that you use the shielding gas. The shielding gas, which is argon, it is protecting the welding from the oxygen and nitrogen that is on the atmosphere. If you do not use the shielding gas, you will have porosity and the welding will be weak, so it can break. So to make sure that your welding is strong, you must make sure that you use a shielding gas. There's many different shielding gases. From air liquid, it has its own, which is alkyl speed. And then also, air product uses argon 5.0. So it is important to use those shielding gases. You can check their properties before you buy your consumables. And in GTA welding, a gas is used as a covering shield around the arc to prevent the atmosphere from contaminating the weld. As I've explained, the shielding gases is there to protect the welding from being contaminated. So your welding will be as strong as the other part of the metal that is not welded if you use the shielding gas. And only original GTA welding has developed to weld corrosion resistance and other difficult to weld metals. So the GTAW has some of its advantages, which it can weld on corrosion resistant steel, which is stainless steel, or you can weld copper. With it, you can weld gold depending on the consumables that you will be having at that time and the shielding gases that you have. And on today, in nowadays, there is various GTAW processes that are being applied to all types of weldings. So GTAW is one of the branches of the welding. We do have many different weldings, which is called MIG welding. We do have stick welding. So those are different processes, and they also weld in different or same materials. And the different will be the tensile strength of the welding after you have welded it, but it is also strong. GTAW welding eventually displays such of a shield metal arc due to the superiority of weld, greater ease of operation, and increased welding speed. So if you are using a GTAW, you can weld at a speed because you'll be having a torch on your left and then having a filler wire on your right. So you can use a certain speed that you feel comfortable in. So, or you can go a little bit slower according to whatever speed you require. So you have control of what is the outcome of your welding. In addition to manual welding, the process can be automated. So we do have some of the robotic machines that are automated to do the GTAW as well. And either case can be used for both light and heavy gauge ferrous and non-ferrous metals. So this GTAW, you can weld on it ferrous and non-ferrous metals. Gas tungsten arc welding. The term TIG welding is the one that is common shop term that is derived from the name tungsten in arc gas welding. So most of the time as you go around, you'll hear people calling it TIG welding, but the other name that is common is argon welding. Argon welding, I wouldn't say I vote for that name as such, because argon, like I have explained, is a shielding gas. The name describes the process and highlights the fact that tungsten electrode and external inert gas are used to produce a weld. So a tungsten is an electrode. Like on a stick, usually we put a stick when we are doing a stick welding. So on the GTAW, we use a tungsten. Tungsten is a very tough material that we use to weld with. So the tungsten electrode doesn't get wear off like a normal electrode that you use in a normal workshop when we are using a stick welding. And then an inert gas is the one that is shielding. So if you can look at a normal electrode, it has a wire, and then it has like a kind of a cement outside, which is a protecting flask. We call that a flask. So a flask is the one that is protecting the welding. So in this instant, the tungsten will be for the electrode, and then the inert gas will be the shielding. Like it will work as a flask to produce the weld. In the text, the term GTAW will be used to discuss this process. The gas tungsten arc welding process may be used to weld most metals and alloys in any position with or without the use of a filler wire. So you will look into whatever process that you are going to use. That does it need wire? Thin material, usually you don't need to use a wire. We call that a fusing. So you will only use the torch to fuse together two pieces of material. But should you weld 3 mil and above, you need to have a filler wire with you so that you can feel the gap that you need to join two metals together. Because of the smaller heat zone and well puddle with the excellent of shielding effect of gases used, the welds produced are often stronger than the weld made with other processes. So it was found that the GTAW, it has more stronger welds than other processes, which is much stronger than the MIG welding, which is much stronger than the stick welding. Although GTAW is slower and produces small weld beads than the SMAW and the GMAW. SMAW is stands for shield metal arc welding, which is the stick welding. The normal one that we use is used even in domestic way, where you can see somebody is having an earth lamp and then has an electrode. They call it what is it called? They call it the rods. An electrode is called a rods. Another name that is known with, they say the welding rods. The welding rods are the welding electrodes. And then we have the GMAW, which is a gas metal arc welding, which is a MIG welding. MIG welding is almost similar to the GTAW, but the GMAW, it uses a core wire that is called a spool. It comes out, and then it also has a gas. It is often the process of the choice of welding thinner sections. Aluminium, specifically specialty metals, and stainless steel. So the GTAW can weld any kind of metal as long as you have the right electrode, and then you have the right gas, and then you can weld the GTAW. And then also it doesn't go with the size of material. You can weld any size with the GTAW. The GTAW, which is a gas tungsten arc welding process, a virtual or non-consumable electrode is used to provide the arc of the welding. The non-consumable electrode, it means that it means they are describing the tungsten. The tungsten is the one that is not consumable. As you can check, the properties of tungsten is one of the hardest metal that you can use. So that is what we use as an electrode for GTAW. During the welding cycle, a shield of inert gas expels the air from the welding area and then prevents oxidation of the electrode. Weld puddle surrounding the heat affected zone. So during the welding, we have an inert gas. An inert gas is one of the shielding gas, like argon. Argon is one of the inert gas that we use to weld the argon welding. So it will protect the puddle, and then it will also protect the heat affected zones. So here we have the gas tungsten welding positions. So you can weld it in different positions, starting from the top 12-0 lock, which is 1F. So you can weld it straight like that, or you can weld it on your top left, top right, sorry. You can weld it 1FR around the pipe. And then also you have a process where you can weld it around with 1G, bottom right, and then also bottom left, you have 1G. You can weld it like that. So you can weld the pipe. So this time you can weld the pipe while you are rotating it. And then as we go clockwise, we have a 2F. That is the position that you can use to weld the GTAW. And then we have the one which is 2FR, where the pipe rotation, you can rotate the pipe as you weld, and then the 2F pipe fixed. So the pipe is fixed, is in one position, you can't move it around, but you weld around it. So it's one of the processes that we use. And then on the left, on the right, sorry, there's a common position that we use for GTAW. So these are the ones that are very crucial. Even sometimes we get it in one of our trade tests. We have a 6G, which on a 45-degree position, 50 millimeter pipe. We also get the 150 pipe also on a 6G. So 6G is one of the welding that is on the right. So I was explaining there the positions there. If you still want this information, I can still mail it to you after this session. And then 5G pipe shall not be turned or rolled. So we also have the 5G position that you can weld with. And then we have a 2G where the pipe is welded horizontally. And then we have a 1G where the pipe shall be rolled as well. We have the 3G where the plates are welded vertical in a vertical position. We have the 2G plates welded in the horizontal position. So this position that I have mentioned on the right-hand side, they are on the left-hand side. So on the left-hand side, we have all the processes that you can use for welding, but the most common ones are the ones on the right. So it is important for somebody, if he's doing GTAW, to be found competent, to be able to complete those 6 common positions that I have just highlighted out of the ones that are on the right, because there we have more than 6 processes. And then for gas tungsten arc welding consumables, and equipment. We have a typical assembling of a torch. For a typical assembling of a torch, we have a back cap. The back cap comes at the back of the torch. And then we have a tungsten. Tungsten is an electrode I was talking about. And the tungsten, you have different tungstens. The tungsten, if you can check at the top of the tip, it has a red color. So it's a color coding. The color coding shows you which material can it weld. So the one that we are seeing now, it's a zirconated tungsten. It is used to weld for carbon, mild steel, most of the common steel. And then we have a thoriated one, which has a white tip. That one you can weld aluminum, stainless steel, and so on. And we also have a collet. A collet also goes inside at the back, but inside the cutting torch, the welding torch, sorry. The collet must have the same size as the tungsten. The tungsten ranges from sizes. You have different sizes of the tungsten from 1.5 to 2.5 mil tungsten. So the collet must be of the same size as the collet, so it can fit. And then also the collet, we have the nozzle. The nozzle, which is also known as the ceramic cup, the pink one, which is the pink one is a nozzle. That is a ceramic cup also as well. And then we have the collet body that comes at the front of the torch. So we also use the collet body. The collet body must be of the same size as well of tungsten. So everything that you use there must have the same size of the tungsten. And then I've also have this video that I wanted to just show, because we are using the Miller machines. They've allowed us to use their video. They say I can go onto their YouTube site and then just show you one of the basic video of how to do a gas tungsten arc welding. Gas tungsten arc welding consumables. As you can see on the right, we have the shielding gas, which is an argon. And argon has two tones, which is green on top, and then we have also the gray part at the bottom. And then also we have the flow meter as well on the cylinder. So the first gauge will show you the content on the cylinder, and the second gauge will show you the pressure that is flowing towards the machine. And then on your left-hand side, we have an electrical welding machine. Electrical welding machine can be used to weld different processes. So this one is one of our machine that can weld TIG welding machine, and also can weld stick machine, and do also MIG welding as well. So this machine is a multitasking machine, can do different weldings, if I can say. But now the setup that is there, because it has a TIG torch, is only for GTAW. I don't know if we do have any questions from you guys, so I can answer any of the questions about GTAW. And then there I have written my email, and then also my numbers. Should you want to know more about other different welding processes, and also should you be around Jet Park or Velcom or Kuruman, so you can contact us and come and check one of our facilities and see what we can offer, what we do offer beside electricity. So yeah. So questions? I see there's no questions. Let me check on chat. Thank you, Toli, for welcoming me. Please note, electrical presentation will follow after this one. Yes, one of my colleague, one of the experienced electrical with 30 years experience will come and do presentation on electrical and connectivity, which is Linda. How do I join the EGD session? I'm not sure. Maybe if you are in the wrong session, you can speak with Melissa. Melissa will be able to assist you with that tech. Goli, please scroll down to quiet events. Pop will ask you whether you want to leave or stay. Thank you very much. Takalani, do we have civil technology floor? Yeah, I think many of the people here, they seem to be lost. They're in the wrong class. But however, I'm glad you managed to join because you have a little bit exposure into our welding. But please, ladies and gentlemen, make sure that you come and see one of our facilities. To what thickness can you weld for proper penetration? Amos, what I can say, the thickness of material depends on the higher of the amperage that you are going to set on the machine. What I can say, if you are going to weld 10 mil flat bar, what you can use to weld on it, you need to put your amperage between 120 amps. And then also you need to push your tungsten out or use a gas lens so you can have extra coverage. So if you are welding a thinner material, you can use 1.5 mil, the ones that usually they use on exhaust to do GTAWs. In Welcome, we are based at President Stein 1, Amos, so you can come to President Stein 1. There we have a lot of offerings from construction. Like I said, we also have electrical, and we also do diesel mechanic, welding, boiler making, fitting and turning, fitting and machining. We do offer a lot of variety, but in Welcome, you can definitely pop in. President Stein 1, you can come through. Adcorp Technical. Is there any questions before I can have Linda on the floor? Melissa to go to a different breakaway session. Okay, thank you, Melissa. So if there is no question and answers, I'm left with 2 minutes, guys. If you still want some more information, you can email me. It's luckym@adcorp technical, luckym@adcorp.com. So thank you very much. Thank you very much, Michael. I think I can leave the room if there's no question and answers. Linda will be on the floor to present. Thank you. Yeah. So, Linda. Mute.
All right, so sharp.
Then you can just edit with your. Everyone. Good. Share. Is it there?
Window. I go to window.
Yeah, go to window. Click here. Share. I want this to make it like. I apologize for the technology. No, it's not our best.
Yeah. Hello, everyone.
Linda,
Hello.
you are welcome to start when you are ready.
Okay. Thank you, Melissa. Apologies for the a minute or two delay. We were, technology at times it can dribble you. So yeah, thank you, Melissa. Hello, everyone. My name is Linda Buthelezi. I work for Adcorp, Adcorp Technical Training. I'm one of the assessors at one of our branches here in Jetpack. Electrical assessor there. I'm a qualified electrician. So I'm going to be presenting basic electrical to you guys. Okay. Firstly, I'll be presenting single-phase power supply. Single-phase power supply is an AC generator, also called an alternator, can be of a single-phase type with two wires. That is a feed, which is our live wire, and a return, the neutral wire. That's our single-phase power supply, where you have the feed, which is our live wire, and our neutral, which is our return. So your live wire, normally it will be in color. For a single phase supply, the color would be brown, or the color would be red. So for the neutral or the return wire, normally it's black, and then you'll have the earth. The earth, normally the color code, it's color coded green or yellow and green.
There's something about the screen not being large.
Okay. Sorry about that. We just want to enlarge the screen here.
Let's see here. And then I need to share. Let's try this. The entire, and then we go here, and then we'll start from the back. All right, we can go to that.
Okay. I hope the screen is now fine. Okay. As I was saying that our live wire, the color is red or brown on the single phase power supply, and then our return neutral wire, normally it's black, and then our earth wire, which I didn't include here. Normally the color code, it will be green, a solid green, or it will be both green and yellow. All right. For example, the examples of single phase power supply, our houses, normally the supply to single phase power supply, your shops, like either your furniture shop or your cafe, you'll have a single phase power supply in those places. Okay. Below there's a schematic diagram of a single phase power supply. As you can see there's your line, which is our live wire, line 1, and line 2, which is our neutral or our return. That white line is our ground or earth. So normally, if you would test for your supply or your voltage, if you put your 2 leads of your multimeter, whichever instrument we're using to test for voltage, if you put one lead on the red wire, which is your line 1, and you put the other lead on line 2, which is your neutral, the voltage that you must get there, it's about 240. And then if you want to test between your line 1 and your earth, the voltage there you would get is about 120 volts, single phase. So your 240 and 120 volts, they are both single phase power supply, or your single phase voltage. Yeah, and then that's your single phase power supply, which we get in our houses and our shops. And then I'm gonna go to our second slide. Okay, our second slide is a 3-phase 4-wire power systems power supply system. A 3-phase 4-wire power supply system is in a symmetrical 3-phase 4-wire. That is a WYE system. The 3-phase conductors have the same voltage to the system neutral, which means that we have when we talk of 3-phase, we are talking of voltage between line 1, as you can see on the drawing below, or the schematic diagram below. You've got line 1, line 2, and line 3. So that's your 3-phase supply, right? Now, when we talk of 3-phase 4-wire system, we are talking of the 3 lines, which is line 1, line 2, line 3, and you've got your neutral and earth at the center of your lines there. So your 3-phase supply, you normally get your 3-phase supply, at shopping malls. You normally get them in industrial areas, hospitals, even in the suburbs or location, you get a 3-phase supply, but to the house, it will be a single-phase supply. So now, for an example, a single-phase supply, if you want a single-phase supply from a 3-phase 4-wire system, you would take either line 1, neutral and earth, and you would feed your house or your shop with that line 1, neutral and earth, and it will be a single phase. Or you can choose either line 2 or line 3. As you can see there on the schematic below, so between line 1 and line 3, you have the voltage there, it's 400 volts between line 1 and line 2. And between line 2 and line 3, you've got the 400 volts as well. Between line 1 and line 3, you've got the 400 volts. So if you test between line 1 and neutral or line 1 and earth, you would get your single phase. So normally we draw single phase from your 3-phase 4-wire system. There's the schematic below that shows you how a 3-phase 4-wire system is like on the schematic there. Okay, so I'll be going to the next slide. Okay, the next slide, we've got our parallel circuit. Our parallel circuit, the voltage or potential difference across each branch of a parallel circuit is the same, but the currents may vary. Parallel circuits are also called current dividers. The reason why the parallel circuits are called current dividers is that, as it says there on top there, that across each branch of a parallel circuit, the current may vary. So normally, examples of a parallel circuit is, lighting circuits at a shopping mall, lighting circuits at home. That's why you get to parallel circuits. And then there's the schematic there. As you can see there on the circuit, there's I1 and I2. So yeah, the current divides there. So the total current from the source, it's gonna divide when you get to A, and when you get to go to R1, there will be a current which is I1, and R2 there will be current that is I2. So when you add I1 and I2, you get the total current from the source, as on the schematic there. So if you want current that's gonna go through R1, there's your your voltage there, and it's divided by your R1, which is your resistor, the first resistor there, or your load. And then if you want current that goes through R2, you've got your voltage there, and then you divide it by R2, and it will give you the current, the total current that's going to go through your resistor number 2 or your load R2. And then when you want your total current, you're going to add I1 and I2 to get your total current that's from the source. Yeah, that's your parallel circuits. These circuits are normal circuits that when you see lights at the shopping mall or at home, you know that they are connected in parallel. If they were connected in series, how you're gonna see the lines that are connected in series is that when some of the lines are brighter than the other ones, or dimmer than the other ones, then you know that probably the circuit there, it's a series circuit. I will explain that on the next slide, which is a series circuit. Okay, we'll be going to the next slide, our series circuit. All right, there's our series circuit. Series circuit is a circuit in which resistors are arranged in a chain. So the current has only one path to take. The current is the same through each resistor. The total resistance of the circuit is found by simply adding up the resistance values of the individual resistors. Examples. An example of a series circuit is a string of Christmas lights. If any one of the bulbs is missing or burned out, the current will flow and none of the lights will go on. Yeah, that's an example of a series circuit, your Christmas lights. So if one bulb, say maybe you've got about 20 lights, if maybe the 15th light has burned out or it's not there, there's the light missing there. So from 1 to 14, the lights will be on, but from 14 until maybe the last light, they will be off. So in a way, like on the schematic below, if perhaps your R2, your 10 kilo ohms resistor, it's burned out or it's not there, which means that R3, you don't get any, there won't be current flowing through 5 kilo ohms R3 resistor. So only 3 kilo ohm resistor will have current flowing through it. So yeah, that's your series circuit. Yeah, so the total current that's gonna flow through the circuit, it's gonna be the same. It's not like the parallel circuit where the current divides. So your parallel circuits, that's why we call it a current divider, and the series circuit, we call it a voltage divider. The current is the same on the series circuit, but the voltage, it's not going to be the same. That is why I said that you'll find that some other lights are dimmer, some other lights are brighter. It's because of the voltage is not enough. So a voltage circuit is a voltage divider, but the current is the same. And the parallel circuit is your current divider, but the voltage remains the same. So we'll be going to our next slide. All right, our next slide is on transformers. We've got 2 types of configurations on transformers. We've got our star configuration, and there's the delta configuration as well, which we're gonna go to the delta configuration after the star configuration. Okay, the star-star connection is generally used for small, high voltage transformers. The ratio of the line voltages on the primary side and the secondary side is equal. So for an examples of star transformers is small, high voltage consumers, like our houses or suburb. I mean, you know, your houses, your industrial areas. You know, they use the star connection, or on the feed would be on the secondary side of the transformer. It will start, because we desire, what we want is your neutral and your earth as well from the start point of the transformer. because you need your appliances like your television, your geysers to work, your computers, your lights to work. So on the secondary side, we normally have a star configuration on the secondary side of the transformer. Yeah, and on the star configuration, the current is the same. Yeah, the current is the same. You know, the voltage differs there. All right, we're gonna go to the next slide, which is our delta configuration. All right, the delta configuration has three phases connected like a triangle. Delta systems have 4 wires total, 3 hot wires and 1 ground wire. Examples, it is generally used in systems where it needs to carry large currents on low voltage, and especially where continuity of service is to be maintained, even though one of these phases develops for that is industrial areas as well. So industrial areas like for an example, like your mines, they use the delta configuration on the secondary side of the transformer. Like, because if you, like on the mines, you know, it's production is 24 hours. So as it says there, it carries large currents on low voltages, especially when continuity of service is to be maintained. So our delta configurations is used, you know, on the mines, the plants, very huge plants where, you know, production, they are pushing production. Okay. We're gonna go to our next slide. Okay, just a second there. Okay, just a second.
Make sure it's projecting. This is that one. That's green. This I told you to look at you.
Okay. Our next, I think, the next one, the one that I have here, I think the next one is about using electrical testing instruments. On the slide there, we've got 4 testing instruments. We've got our first instrument, which is our multimeter. Our multimeter, we can use it for a couple of things, like to test your voltage, to test your DC voltage or your AC voltage. AC voltage will be your voltage that you get, you find it in our houses, you know, shopping malls, and then you've got the DC voltage, which you can find it in your car. Our cars use DC voltage. You can test resistance with the multimeter. You can test continuity. You can test your diodes, your capacitors. You can test your amperages on how many amps is your motor or your circuit breaker is pulling. And then our next testing instrument is our line, a non-contact voltage tester, where that one we can test just by putting it on like for instance, an extension cable. You just put it on the extension cable and you press the on and off button, and it will beep. And then
Okay. Okay.
Just a minute.
Okay, please hold on just a minute.
Just stop sharing and just continue talking. Yeah. We can just continue. Stop
All right.
sharing.
As I was saying, the other testing instrument is our non-contact voltage tester. Just put it on your wire, and then you press the on and off button, and it will beep. If it beeps, then you know that there's voltage on the cable or your extension. And then our third testing instrument, we call it a tongue tester. Tongue tester, we normally use it for testing current, and it can test also your voltage, your amps, but mostly we use it because it has that round thing. We normally use that round thing to test our current. We call it a tongue tester or an amp probe to test our how much is your transformer or your motor, how much current is it pulling, especially when you have faults like maybe your motor is pulling, because obviously motors are designed to pull up to certain amps. If your motor is tripping, tongue tester to test how many amps is your motor pulling. If your motor is pulling 5 amps and you use the tongue tester and you get that the motor is pulling more than 5 amps, then you know that there's an overload. The motor is pulling more than a lot of amps, more than what it can handle. And our last testing instrument is an insulation resistance tester. That testing instrument, we use it for testing our insulation on the cable. If the insulation is still okay on the cable. Normally, if a cable keeps on tripping on the transformer, whatever it feeds the cable, we test the cable with that meter. It will tell us if there's a short on the conductors in the cable. And we also test transformers with that testing instrument, the windings of a transformer if they're having short, and although on the motor as well, we also use that meter to test the windings of a motor if they're having short. So we've got a range of testing instruments. I just use those for, we've got, your infrared where you test if ever your transformer, there's hot connections on the transformer. We've got your PSC loop testers. Those ones, we normally use them when you do a certificate, the COCs. So there's quite a range of testing instruments. That was my last slide. I think we can pose questions if there are any questions. Yeah. Okay.
And the boxes in it.
Click here.
Then you can click them there. Okay. And then you can go back to chat participants. Chat. And answer them.
You see the boxes in it.
Answer them as you speak.
You can hit just the common discussion. I can't see this call from this now.
Okay, I see there are no questions. I don't know if this technology, I don't know. If there are any questions, please guys, you can pose questions.
My email. Ubuti Q&A. Open both chat and Q&A. If there's nothing, there's nothing.
Yeah, I got a question.
Hi, Melissa. Okay. There's some question in the chat.
Hey man, there's nothing.
Okay, thank you, Melissa.
Go down, buddy. Go down. Usatama fast. You need to read and answer.
More down. Okay, just a second, guys.
See, there's something.
Linda, maybe I can read quickly for you.
Come
So
again,
the
Melissa?
first question was, in transmission, do they use the delta connections or the, I'm not sure how you pronounce it, WYE or Y connections?
In Delta connections.
Yeah, in transmission, which do they use delta connections or Y connections?
In transmission, they use the in transmission they use the Delta connections.
Okay, perfect. And then the other question was, can you please clarify transformers again?
Clarify transformers.
Yes.
Okay, let me go to the slide. Okay, on the transformers, our star configuration. Normally, our star configuration, we normally use our star configuration. On the secondary side, there's primary side and the secondary side of on transformers, right? So, our secondary side normally in the locations or suburbs or residential areas, we use on the secondary side it will be configuration because we need a neutral and an earth as well for your appliances to operate or to work. So yeah, that's why on the we use the star configuration for your residential areas. And then our delta configuration, we normally use our delta configuration because we need large amounts of current. So those ones are normally used, like for instance, if there's a mine on the secondary side of the transformer, it will be a delta configuration because in the mines the production is 24 hours and you need large amounts of current. I hope that I've answered. Okay.
I don't see any more questions.
Questions?
Is your presentation done?
Yeah, I think I'm done, Melissa. I'm done.
Okay, fantastic. Well, thank you so much for joining us. If we can just ask everyone, will be ending the presentation shortly. So just join us in the main discussion room or the main breakaway room for final discussions at 3:30. Thank you so much.
Thank you, Melissa. Thanks.